Welcome. Today I want to take you through these reagents and how they are used and what you are expected to write. Now we talked in our previous lesson about the reagents, which you must understand how they are being used and what you are supposed or what they mean. For example, I have here different reagents, and I want to begin with the one that is more commonly used in our first question. You find that you are told to the first portion, add sodium hydroxide solution dropwise until in excess. Here you expect two observations. You expect that white PPT is formed soluble in excess. A white PPT is formed, which when you put in excess, it dissolves to form a colorless solution. So if that happens, if you are adding 2 drops of sodium hydroxide, and then when a white precipitate is formed, once you add in excess, the white precipitate dissolves to form a colorless solution. Then it means that the inference is that the amphoteric ions are there. The amphoteric, we have 3 of them. That is a word we use, ZAP, meaning that the zinc ions, aluminium ions, and lead ions. Therefore, it means that aluminium, zinc, and lead are present. Now, what is the understanding behind this? Aluminium oxide or hydroxide, zinc oxide or hydroxide, and lead oxide or hydroxide, these oxides and hydroxides of these metals are amphoteric. Amphoteric meaning that when they are in a basic solution, they behave as acids, and when they are in acidic solution or environment, they behave as the base. Now we are adding a base into a solution we don't know, and then this solution forms a white precipitate, which then dissolves to form a colorless solution. That is a neutralization reaction. So it means a base and an acid has reacted to form a colorless solution, which is water, right? So therefore, we take this one, the amphoteric ions, which are going to react with the base. They are going to behave as an acid to neutralize this one to form a colorless solution. Another observation we expect here is that white PPT is formed insoluble in excess. So if a white precipitate is formed, you have added to 2 drops, a white precipitate has been formed, and then when you add in excess, the white precipitate remains. It means that the white precipitate is insoluble in excess sodium hydroxide. If that is the case, then what it means is that there are several ions which could be now present, because here, if it forms a white precipitate and which does not dissolve, so many, there is barium, 2 positive, magnesium, 2 positive. There are so many ions which are present. So many calcium can be there because it is forming a white precipitate. So, but in this case, we only give 3: barium 2 ions, magnesium, and even calcium 2 positive. You will say this is present. This one could be present if it is insoluble in excess. Suppose now it forms a different color. you are adding sodium hydroxide, then it forms a blue PPT. A blue PPT which does not dissolve in excess. A blue precipitate which does not dissolve in excess. So if it forms a blue precipitate insoluble in excess, then definitely it is copper 2 ions which are present. Copper 2 ions are present. What if it forms a green precipitate? Green PPT is formed insoluble in excess. So once a green precipitate is formed, then it says, and it is insoluble, then iron 2 ions are present. Iron 2 ions are present. Lastly, a brown PPT insoluble in excess. A brown PPT precipitate insoluble in excess. Actually, that confirms the iron 3 ions present. So we have done with sodium hydroxide as a reagent. So these are what you are expecting when you are using sodium hydroxide. The next reagent is ammonium solution. Ammonium hydroxide, or they call them ammonia solution. Ammonia solution, you expect also several observations. So it is good you understand all of them. You expect several observations. So we want to start observation number 1. Observation. And then we will have the inference. White PPT soluble in excess. So if you are adding ammonia solution, a white precipitate is formed, which then, after you add in excess, this white precipitate dissolved to form a colorless solution. That simply tells you that it is the zinc 2 ion that is present. It forms a white precipitate. Then when you put in excess, it forms a complex, which we call tetraamine zinc 2 ions. So it dissolves to form a colorless solution. So therefore that confirms that it is zinc 2 ions that are present. What if it forms a white precipitate? White PPT insoluble. The one that does not dissolve in excess. Yeah, it has formed a white precipitate. When you add sodium hydroxide in excess, the white precipitate persists. That means the white precipitate is formed, which is insoluble in excess. What does it mean? It means that so many ions could be there. It means that barium 2 positive can be there, lead 2 positive, aluminium 3 positive, magnesium 2 positive. So many ions are present. That's what it means, present. Because all these ions, they form a white precipitate with the hydroxide. Barium hydroxide is a white precipitate. Lead hydroxide, aluminium hydroxide, magnesium hydroxide, all these are precipitates, and they are white and they are insoluble. So it is only zinc hydroxide which dissolve in more ammonia to form a complex ion, which is tetraamine zinc 2 ions, and then it dissolves to form a colorless solution. So that's how you identify that. And then there could be no white PPT, because here we expect a white precipitate, no white PPT. If there is no white PPT and you are adding ammonia, it means it forms a soluble salts, and we have soluble salts. The only soluble salts we have is the salts for potassium, sodium ions, sodium salts and potassium salts. All of them are soluble, therefore it forms that. And yeah, so these are the major which could be present. The next observation, when we are using ammonium hydroxide or ammonia solution, we expect a blue precipitate which dissolve to form deep blue solution. When you are adding ammonia in drops, you form a blue precipitate, 2 drops. Then when you add more in excess, ammonia in excess, a deep blue solution is formed. So that confirms that copper 2 ions are present. Inference. It confirms that copper 2 ions are present. The next two is that if it forms a green PPT insoluble in excess, it is simply ion 2 ions present. If it forms brown precipitate insoluble in excess, then it confirms that it is ion 3 that is present. So we have done 2 reagents, that is sodium hydroxide and ammonia solution. So let us go to another reagent when we use sodium sulfate. What is sodium sulfate testing? When you add sodium hydroxide in 2 drops, then a white precipitate is formed. You are adding 2 drops of sodium sulfate, a white precipitate is formed. So that simply tells you that inside there could be lead ions. Why lead? Lead plus sulfate, it forms a white precipitate, which is lead sulfate. So this one combines with lead to form lead sulfate, which is a solid. Another ion which could be there that combines with the sulfate, there could be barium, because barium sulfate, red sulfate are insoluble, they are white precipitate. So it means that inside there could be barium. Another cation which could be there, it is calcium. Calcium, when you add sulfate, it forms calcium sulfate, which is insoluble. Therefore, if you add sodium sulfate, a white precipitate is formed, then lead 2 ions, barium ion 2, and calcium ions are present. So these are present. That's what it means. Now, the opposite is that the other observation is that no white PPT. No white PPT. So if you are adding sodium sulfate, then there is no white PPT. It means all of these 3 cations are absent. You write that lead 2 positive, barium 2 positive, and calcium 2 positive are absent. So that is the work for sodium sulfate, it is simply want to test for these three insoluble salts. Now the next reagent I want to use is potassium iodide. Potassium iodide. Potassium iodide is used to test for lead ions, especially lead. When you add lead ion, for example, you are told that into test tube 3, add 2 drops of lead. Then there we expect, whenever you are using lead, potassium iodide as the reagent, you expect a yellow precipitate. It is either there is a yellow precipitate or there is no yellow precipitate. So whenever you are adding potassium iodide, if this is an halogen, so you expect a yellow precipitate. This yellow precipitate, it is a precipitate of lead. So if there was lead in that solution, it will form lead iodide. Lead iodide is yellow. So if you add 2 drops of this, a yellow precipitate is formed, then it means this one is present. So the alternative is that there is no yellow PPT. The other observation is no yellow PPT, and then you say lead 2 ions absent. Lead 2 positive absent. So we use this one to identify lead ions. The next reagent we want to use, we had several. We have talked about this, and this one, and this. So we are coming here, barium nitrate. Now we are going to barium nitrate. The next reagent is barium. Let us use barium nitrate. Sometimes we can use barium chloride. So whenever you are using barium nitrate or barium chloride, we are interested with these ions there. So add 2 drops of barium nitrate, then a white PPT is formed. So when a white PPT is formed, it means that this barium entered into that solution and met with the sulfate, met with the carbonate. So inference. This is the observation. It means that this barium entered there and it met with the sulfate ions, then it formed barium sulfate, which is insoluble, or it met the sulfite ions, and then it forms barium sulfite, which is a white precipitate, or it made a carbonate, then it forms barium carbonate, which is insoluble. Remember, all carbonates are insoluble except that of potassium and sodium and ammonium carbonate. So the rest are white precipitates. All sulfates are soluble except barium sulfate, calcium sulfate, and lead sulfate. So that is the knowledge that is used here. So if a white precipitate is formed, you are adding barium nitrate or barium chloride. We are interested with these 3 anions.